I'm Josh Kromek, and today I'm going to be going over mechanical transmission oil pumps. To get a better idea of how they work, I'll be focusing on a 4L80 from a GM transmission. Throughout this video, I'll be going over the purpose, common failures, operation, and even diagnostic techniques of this pump. Let's get started. So as I said before, this is an oil pump from a 4L80 transmission. It is located at the front of the transmission, but also behind the torque converter. The purpose of this pump is to build hydraulic pressure in the transmission and disperse it appropriately so that all of the clutch packs, solenoids, valves, and even the torque converter functions properly. Now this pump should generate at idle a pressure of about 50 psi at 1 amp at the solenoid. Now at full throttle, it should generate 175 psi at about 0 amps at the solenoid. This is also a fail-safe, so if the solenoid fails, the transmission will always have high pressure. So how does this pump produce so much pressure, you might ask? Simply by a torque converter spinning a small gear inside of the pump that meshes with a larger gear, sucking fluid in through a large area and pressurizing it through a small area. Now this pump is also called a crescent pump. As you can see here, it has a crescent shaped casting. As we take a closer look at the small gear, you can see that there are 2 notches. These 2 notches fit onto the torque converter. Note, you have to be careful if you ever reinstall this gear because the 2 notches themselves have inner lips, and if you install it upside down, this could cause damage in the future or as you put the transmission back together. So, as the gears spin, fluid is sucked in the inlet, and this large gap creates a suction, and it spins. Fluid is moved through this passage into this smaller area. This is where it gets pressurized and goes out the outlet into the pressure regulator. Alright, here we have the other half of the pump body. Here we also have the pressure regulator valve. Now, as pressure comes in the inlet, here, also this side, on this side of the pump, it travels around the pump, it gets pressurized here, which is also this side. Fluid passes through here, it comes in this hole, and also down through here. When pressure comes through this hole, at a certain pressure, the valve is pushed a certain distance, fluid passes through here, and gets sucked back into the inlet and gets recirculated. Some of the common failures of a transmission oil pump are usually due to lack of maintenance, lack of fluid, also overheating, and also could be caused by dirty fluid. You can also get, with the dirty fluid, debris in the fluid, and that can cause damaged gears and also worn valve bores. When we talk about overheating, this can cause the pump to be warped, and it also can again cause damage to the gears and scoring. Diagnosis to this pump is limited because this is a component that is inside of the transmission. Because of that, I will describe a few ways that you can diagnose from outside of the vehicle or from sitting in the vehicle, and a few ways where we can bench test it. First, I'll talk about how to diagnose from inside the vehicle. One good way that you can diagnose it is to get in the vehicle and drive it, and to verify that it goes into all the gears. If it does not go into the gears, this could indicate a bad pump and low pressure. Second, you could get a pressure gauge and tap into a transmission fluid line and see what the pressure is at idle, again before we said about 50 psi, and also at full throttle, which would be about 175 psi. Alright, now we will be performing a diagnostic procedure of hooking up a gauge. In this instance, we will be hooking up an electronic form of the gauge called a pressure transducer. Here we have the Pico connected to the transmission with the pressure transducer. Over here we have a scan tool. With this scan tool we will be able to command the pressure solenoid in one 0.1 amp increments, up or down, and we will be able to see the pressure decrease or increase depending on the command. So here we'll go to functional tests, go down to pressure solenoid, put the S for test, and as these amps go up, the pressure will also go up or down.
Going real slow.
All the way up to 1 amp. As we start going back down in amperage, the pressure will begin to increase. This is also a good diagnostic procedure to make sure the oil pressure is sufficient. Also, this is a good way to see if the solenoid is working properly. If you don't have a scan tool that has the correct functions to operate and control the solenoid, here's a test that we can do to see if the control solenoid is providing the correct amount of pressure to the pump. What we do is just rev it up to about 3,500 RPM, and then we'll shut it off. And what that does is when we shut it off, it should reach its peak pressure. And then on the computer here, you should see it spike up and then drop back down. And that's the test. Another indication that you might have a bad pump is when you're driving the vehicle, if you listen for a whining noise. Also, if it is in a stationary position, if it continues to whine, this could be a sign of a faulty pump. Also, when you're diagnosing that, be careful because a clogged inlet, which would mean a clogged filter, could also result in a whining pump. Now, we can go to talking about how to bench test a transmission oil pump. Alright, one thing you can do is you can use a file. This is going to check if it's warped. So what you can do is lay the file flat on the pump and go back and forth with a little bit of pressure. You can also do it on both sides. Now what this does is if you see any shiny areas, this would mean that there is a high spot. On this pump, it looks pretty clean. You can see a few areas along the edges where it's a little bit shiny, but this pump is okay. If you have major areas where it's shiny, where when you were filing you felt like it was harder to push the file, this could indicate a warped pump. Alright, for this diagnostic technique, we'll be using this straight edge and a feeler gauge to check between the height difference of the pump body and the gears. Now, the reason we do this is because if the gears are too low, it could allow fluid to pass through and to leak out, causing a lower fuel pressure or oil pressure. But if the gear is too high, then it won't be able to spin, and the gears would lock up once you put the two pieces together. So what we're going to do now is take our smallest feeler gauge, which is 2/1000, and it should fit underneath here, which it does, pretty snug. Specs from this pump go from 8/10,000 to about 3/1000 clearance. They should not exceed that, otherwise you will have symptoms of leakage or gears locking up. The last thing I will discuss when you have it on the bench is if you take the gears out, if you put the gears together, You should not be able to pull them apart. If the gears pull apart, then they are too worn and they should be replaced. Now with these diagnostic techniques, you should be able to determine whether your pump is faulty or whether you have another fault in your transmission. Overall, I hope this video gave you a greater understanding of how a general transmission pump produces pressure, and also, even more so, how to identify if it is faulty. Thanks again.